All right, guys, so don't forget now, today's is another quiz. Yay! What is going on there? It's neat. Whoa. There, sorry. So let me show you something real quick here. I'm almost certain you've gone into Canvas at some point. I just want to show you. You can't see all this. This is my screen. But the quiz for today will show up right here. As soon as I see how it's not published yet, ha 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 ha. So, but that's exactly where it will be. It will show up right there. So after today's lecture, it'll show up right there. It's about correlation, of course. So if you guys have any questions, now would be a great time to ask. Okay. All right. Looks like everybody's okay. Let's see. And I still got to put the chapter 11 homework stuff up here, but I will eventually. Okay. Oh, I stopped sharing, didn't I? Oh, well. Yeah, but I haven't put chapter 11 stuff up there yet. So, like 11.1, 11.2, whatever. Anything from homework, anything related to the quiz today? Any questions? You guys doing all right? I don't know if you guys noticed. Let me share my screen again. Where'd it go? There it is. I also, where is it? Yeah. So if you click on this one, side one of Goodness of Fit Correlation Practice, it's a video. It's actually a video from, I think, last semester, from when, you remember the before times when classes were in these rooms? So it's a video from those days, from my last semester stat class, I think it is. And it goes over that, the sheet. Oh, you could do it, Jeff. Can you? Yeah, there you go, buddy. Look at you. This one. So on the other side of this, there was that problem about amount of money made and bachelor's degrees, right? So that's the video showing that one worked out. Okay. Any questions about that? Anybody confused? Anybody questions? All right. Okay. So let's get back into where we left off. If there's no questions, I'm going to jump right back into chapter 11. Declare bankruptcy. I mean, it's the one about chi-square stuff, right? Goodness of fit stuff. Okay, so let's do this. Let's do a problem. Let me turn off my black hole. I love saying that phrase. All right, black hole. Thank you. Let me move my light source. That's what it is. All right, come here, lights. All right, so let's do an example, sort of different from what we did last time. Let me just say last time before myself. So remember, all right, so if you weren't here on Monday, you definitely want to go watch that video because we introduced a brand new distribution. So there's a new chart to reference, all kinds of neat stuff. Okay. So let's try a different kind of problem. Let's say that I expect this to happen. Let's see, what can I say here? Yeah, let's just make this kind of generic. All right. So there's these 4 categories. Gray, it could be gray, I don't care. Just 4 categories, right? And I expect 10% to be in this category. I expect 30% in this category. I expect, what do you got, Jeff? 20% in this category, and that leaves 40% in that category. Let me stop for a minute. So you guys understand so far. So I've got these 4 categories. I can even make them line up. That would be amazing. I got these 4 categories, and that's what I expect to happen. I expect 10% of people to be in this category and so forth, right? So let's say I have 400 people. How many do I expect? All right, I love you guys. I know this is early for this stuff, but it's not as early as it could have been if we were still on campus. If I take 400 people, how many do I expect to be in category A? Yeah, I love it. Thank you. All right, sweet. That makes me feel a little better. Somebody not only is there, but they're also awake enough to. So good. So I expect 10% to be there. 10% of 400 is 40. And then 30% of 400 is what? Yes, 120. And then 20% of 400 is 80. And then 40% of 400 is 160. Okay. You're all like, no, Jeff, no. Speak English. All right, I'm sorry. Thank you, Kate. All right, so this is different from what we did last time. Last time it was, I wish I could remember, but it was a uniform, oh yeah, it was rolling a die. Remember this? We rolled a die. I didn't have any percentages to work with because it was a uniform expectation. I expected them all to be the same. So if this was a uniform, I would have taken 400 divided by 4. It would have been 100 each. Uniform meaning all the same. This is the second type of goodness of fit we could do. Not a uniform expectation, but a percentage breakdown amongst categories. Welcome to whoever came in. All right. So now I tell you what we observe. We observe these. What do you got, Jeff? 10, 30, 40. We observe those. We observe those. Can I speak? You observe those results. There it is. God, I'm shaking a lot. Sorry. All right. I can't touch the table. Now, just on site, what do you guys think? Is that very different? Did what we see, was it different, very, very different from what we expected? I mean, you can give a guess. It doesn't seem to be, does it? But again, very often our intuition is wrong. But I would agree with Olivia. I would say this doesn't seem very far off, right? So the whole idea is, oh geez, I left myself no room. I wish I could think ahead. That would be amazing. All right, you guys will forgive me. Will you forgive me? I don't know. Screw it. Let's just go for it. So observed minus expected squared. Right. So again, last time we talked about this, this makes nothing but sense. This whole idea is how different is what I see from what I expected to see. So obviously subtracting those should be a part of it. I square that for much the same reason we squared when we did the standard deviation equation, right? And then the last thing we're going to do is divide by the expected to see how relatively big the difference is. So a difference of 10 is huge if my numbers are 1, 2, 3. But a difference of 10 doesn't mean anything if my numbers are 1 billion, 2 billion, right? So I need to see the relative difference. So what do I get here? 100, right? Is that cool? 10 squared, 20 squared, 400, 10 squared, 100, and then 40 squared. You can do it, Jeff. Is that 1600? Let me stop for a minute. No, it isn't. Oh no, that was from before. I can't remember. Okay, you guys all cool with those numbers? Anybody not cool with those numbers? Let me just stop there and say that. Now, unfortunately, I didn't plan ahead. There would normally be another column over there, but I'm just going to have to put it down there. So you guys are just going to accept that that's happening. So the next column would be this one. Divided by the expected to see relatively how big the difference is. Why did I write so big? I don't know. Don't worry. I'll move this up so you guys can see it. So if I do 100 divided by 40, is that 2.5? Yes. If I do 400 divided by 120, oh shit. 100 divided by 30, 10 divided by this, 3.33? What's 400 divided by 120? Is it, yeah, 3.33. 100 divided by 80 is 1.25? I think so. And 1600 divided by 160, that's an easy one. I thought maybe. Okay. So if you missed last class, this is interesting, this work, because another way I could have taught last class was to do all this work first and then talk about, well, how can we interpret what we get? Because I'm going to add these up. It would sort of be an accumulation of all the differences. So I get that one number, and then what do I compare that number to see if they're different enough? So again, just to remind you guys, if there was no difference between what I see and what I expect, these would have all been 0. The bigger the results of this, the more different they seem to be, right? And they have to be different enough. So let's get that. So if I said alpha is what, Jeff? 0.10. Anybody remember what my degrees of freedom will be? Degrees of freedom. Degrees of freedom. Degrees of freedom. Yes, 3. Now, this is up on the, shit, there it is. This is up on the on Canvas. So the chi-squared chart, right? So it pretty much is very similar to, it isn't really, to be honest. There's 3, and then I find my alpha up here. My alpha's what did I say? 0.10? It's the first one over there. There, see? There it is. And then I just go down and stop at 3. So I get, apparently, 6.251. Is that right? 6.251. You guys could. That was too close. Sorry. So this is what it looks like. It looks exactly like Jabba the Hutt. Big old tail, little face here. And my critical region then is going to be anything past 6.251. All right, let me stop for a minute. As much as we despise hypothesis tests, possibly, I don't know, maybe somebody out there likes them. It did make us familiar with the idea, and this is a very watered down version of hypothesis test. I'm not going to make you do all the steps. You do this, and next thing I got to do is add those up. This is my chi-square critical region, right? The rejection region. This is a chi-square. And this, if I add these up, that's the formula for chi-square star. All right. Just add these up. So what do you get when you add these up? 2, 5.58, 8.08, 17.08? What the? Oh, that's a 10, Jeff. I was counting as a 1. Shit. All right, so 17.08. I like it. So our intuition, was our intuition earlier correct? Or what have we discovered? Let me see how creepy I can look. Whatever he discovered. Did we, so remember, what would it mean if I got right there? If I got 0, what would that mean? What would 0 mean? If I added these up and it was 0, what would that mean? What would that mean about what we see and what we expect? We could do it. If I got a zeros here, what would that mean about what I observed and what I expected to see? They would be, what's the only way that I can get zeros? When I subtract them. If the observed and the expected were the, okay, if they were the same. I don't know if you guys just don't want to say it because it's too obvious. I don't know. But if the observed and the expected are the same, that's the only way I can get 0. So the further away from that I get, the more difference there was between those. So this is like the critical region. This is the how far I've got to get to show evidence that it's different. So we had to get 6.251, and we got 17.08. Holy shit. So we have blown it out of the water. We have found evidence that this group does not follow the expected. Yeah, it's way off. Yeah. Even if I would have used alpha of 0.005, I would have still blown it out the water. Yeah. So see how that goes directly against our intuition. And that's because statistics is so weird. Our intuition is not geared towards interpreting these kind of things. It isn't. So that's why we need some help. So what I would write is, we have found evidence that the group is different. Oh my God. Oh God. Okay. Enjoy that. Okay. So let me read this for you. Okay. Sorry. Let me try it. We have found evidence the group is different. The group that we're looking at, the observed group, is different from what was expected. Now, in reality, I would give you some context, right? You have to include that here. Maybe this was, all I can think of is blood cholesterol level, because that's what we're going to do later. I don't know. Okay. So let's do this. Let me sit my ass down. Come back over here. Oh, did you guys all get that? Is that? Okay, so let me show you this. Let me see. Where did I put this at? There you are. Is that you? No, that's you. Yes. Okay. So let me share this. Boom, boom, boom. All right, this is that sheet that I pointed to last time. Oh, sorry, Olivia. Let me come back. If anything in here is not far enough away from 0, and 0 would mean these are the same. So anything in here is not evidence against them being the same. I have to get so far away, at least this far away, to show evidence that they're different. So whoever this group is, let's say these are, I'm not creative this morning. I have no idea. Let's say that these are, shit. What are these? I don't know. So let's say these are grades. Yeah, sure. Thanks, Olivia. Olivia's like, dude, just say something. Okay, let's say these are grades. And this is what I expect to see as a breakdown of grades. And I take a certain group of people, and this is the breakdown. Right? Now, what's interesting is the minute I say grades, when you look at this, do you see how more people failed in this group? All right, less people passed, less, and then more. So if I would have said grades, I think more of you would have said, yeah, they do look very different. Maybe. I don't know. That's my first intuition. So if I don't get past this, that means that this sum of all these relative differences wasn't big enough to be evidence that they're different. We did get past that, so we have found evidence that this group is different. They didn't follow the expected pattern. Does that make more sense? Okay, so remember, what's really nice, you got to keep in mind, 0 means no difference. So if you're a little different with a sample, who cares? A sample is going to be different, right? You take a sample, it's going to be different. I'm sorry, you're going to roll a die 60 times. You're not going to get 10 ones and 10 twos. You're not. You're just not. Could you? Yeah. Is it likely? No. So not only does it have to be different, it's got to be different enough. And we should be very used to what I just said, the different enough. That's what this critical region is, right? The rejection region. How far away does my sample have to show up? Hopeful. Okay, all right, sorry. So coming back to this thing. Let me see here. Oh, gee. So up here, I've got a worked out example. Oh, by the way, real quick, before I forget, this side is the one I was talking about that the video up there on Canvas is all about. It's me in a class last semester explaining how to do this and then explaining the answers to these. So you can watch it, you can not watch it. It's totally up to you. No skin off my nose. But here's an example of the type of goodness of fit test that we did on Monday. Do you guys see why did I put nothing but 7s here in the expected? The observed, I've got to tell you how many of each. So why did I put nothing but 7s in the expected? Maybe I was crazy. Maybe I just liked the number 7. I like 7. So how many total M&Ms do I have? 42 M&Ms, right? And how many categories are there? 6 categories, right? And the whole point of this is to see if they are uniformly distributed, which means each category gets the same amount. So I equally divide 42 amongst the 6 categories. 42 divided by 6 is 7. Right? So thankfully there weren't 5 categories, but if there were 5 categories, 42 divided by 5 would be 8.4. So I would have put an 8.4 in the expected. Why is that okay? I'm not going to get 8.4 brown M&Ms because it's an average. It's expected, which is nothing for average. Average could be 8.4, right? Yes, Jeff. Okay. So very quickly, this is already worked out for us, but here's the observations. I collected that from what they told me. Here's the expected. I worked it out like we just talked. Anytime there's uniform distribution check, I take the number divided by the categories because each one's supposed to get the same amount. That's what uniform means. Then I did this check to see what the differences were. And then I did the division to make them relative difference, right? How big is the difference relative to what the numbers are that we're talking about? And added those up, that's my chi-square. That's like the accumulation of all the differences, the relative differences. And sure enough, 3.14 wasn't big enough. Look at that chart, by the way. That's really good for me. I'm sorry. Past Jeff really took some time. I made that, by the way. I didn't just find it. I made it. I'm so happy. I'm so proud. And it's not that good. I'm sorry. This was the rejection region because alpha was 0.05. You can double check. Can you guys find 11.071 on the chart? Alpha, let me put the chart up here in case, I don't know if anybody doesn't have the chart. So degrees of freedom is 5, right? 6 categories. Degrees of freedom is 5. Level of significance, the alpha is 0.05. So let's take a quick look just to make sure everybody's with me on this. There you are. Right? What was it? I just forget. That's amazing. It wasn't 0.05. I think it was 0.05, right? And the levels and the degrees of freedom is 5. So there's the 11.071, right? Maybe. Where'd the problem go? There it is. So that's the 11.071 I got right there. So that's kind of like the rejection region. There's the rejection region. I got it all shaded, all nifty. And then I plotted my chi-square star, the one I get from my sample I took. Here's my sample I took. And this is the calculation of this. This is very similar to calculating Z star and then seeing where it falls. So that part of the hypothesis test is normally the part that students really kind of get. I mean, that's a nice visual. So yeah, we didn't make it far enough. We have not found evidence to reject the claim that they are uniformly distributed. We didn't find enough evidence to say that they're not uniform. Guys, semi with me? So yeah, we got more blue than expected, but not enough more, right? It wasn't far off enough to complain. All right, if your life is consisting of writing letters to the M&M company, the whatever they are, you need to reconsider things. So what I want you to do right now, I want you to do this right now, is this problem, number 2. Let me zoom in a little bit. Ha! Get in there. Anybody not understand what's happening right now? I need you to do number 2, problem number 2, right now. I'll wait. If you have any questions, let me know. I want you guys to get started a little bit, and then I'm going to break you up into groups. And I break you up into groups so I can see who's really here. Because whoever's not really here won't go into their group. So that's always a neat time for me. So hopefully everybody's actually here. God, this is so weird. I have no idea. I could just be sitting here talking to myself. Oh, Olivia was talking to me earlier and Kate was. Okay. All right. I feel a little better. I think for the final, I'm just going to put he's going to videotape me looking like this. And just keep it on a loop. And then I'm going to go back to bed. I might not do that, so be careful. All right. Let me check in with everybody. Do you guys see where to put the numbers, where to get the numbers that go here? What numbers are going to go in here? What number will go right there? Anybody? What number would go right there? I tell it to you. I just tell it to you. Yeah. 132 have a level below 130 and so forth. All right. All right. What number would go right here? So let me put that right there. So 132 have a level below 130, right? Can somebody figure out what number would go right there? How do you figure that out? Don't tell me the answer. Tell me the work you do to get it. Can somebody tell me that? 20% of? 20% of? Yeah, 20% of 500. There's 500 total people. I was really nice, and I told you the total. And I know that I expect 20%. Good. So 20% of 100, I'm sorry, 20% of 500 is 100. All right, and then you can fill in the rest. So I'm gonna go ahead and break you all up into groups. Keep working, keep working. Oh shit, this sucks. You guys are gonna have to copy down enough of the problem so you can do it together. I'll give you guys a minute before I stop sharing my screen. If you're not sure what to do, at least copy down the information. So then when I break you out in groups, maybe somebody can help you. Okay, I'm going to stop sharing now. Anybody freaking out about that? I'm going to stop sharing the screen. Hopefully everybody's got the information they need. Okay, here we go. And then I'm going to break you out into rooms. There should be 3 people in each room. Let's find out what happens. Ooh, what's this? Oh, sorry. Oh, I could do that. No, I'm not going to do that today. All right, sorry. Here we go. I didn't realize how much control I have. Is anybody really here? Go to your rooms. Okay, I see a few people. 2 people have moved into their rooms. 3 people. Ah, ah, ah. 3. Oh, there we go. Let's see who's not really here. There we go. Sweet. Everybody's here. Yes. They can't see me now. Oh, this is still recording. Ha, ha, ha. I'm going to blow my nose. La, 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 la. All alone, all by myself. Oh, it's weird. I don't know. Something's weird. I could have paused the recording, but I didn't want to. All right. Jeff, whatever, man. All right, let me see what happens. Let me close the rooms. Maybe? Is it a good time? I want to give them time to hang out. They would have come back if they weren't having a good time. I got sunshine on a cloudy day when it's cold outside. You're the month of May. Well, I think I should probably bring it back. I'm going a little crazy. I guess you'd say, what could make me feel this way? My girl, my girl, my girl, talking about my girl, my girl. I got sunshine. Oh, I could have done the prom, but oh well. When it's cold outside, the month of May. Well, I guess you'd say, what could make me feel? Oh shit, Jeff. The rest, dang it. 2, 4, 20, 452. I think it's 48, right? Maybe. Oh, they really don't want to come back. Let's see, 20%, 30%. Almost 150. Oh shit. Let's see, 35%. What would that be? I don't know. 10% is 50, 25. So it'd be 175. Is everybody back? Yeah. Okay. Did I cut that off too soon? I couldn't tell.
Yes, a little bit.
Sorry? A little bit too. I'm sorry. I never know. Let's check in here. Do you guys getting these that I'm putting down here? Let's see. Did I do these right? Is that the same numbers you guys got? I'm trying to do this in my head. Hopefully that's right. Anybody? Did you guys get those numbers?
Wait, where's the numbers?
We only
Oh,
see you.
oh.
We
Oh,
only see you.
all right, I know. Sorry. All right, is that better? Are those the numbers you guys got?
Yes.
Okay. All right, I like it. I'm not sure how far you guys made it. So these numbers get a little bit gross, but hopefully you guys got calculators. So what did you guys get here?
1024.
1024? Okay, sounds about right. Let's see, let me make all these red. Bam. Why are you guys, hold on, I can't let this go. Okay, there you go, Jeff, you're fine. And then here you get, geez, 70, 4,800, miss 4,000 something.
200.
Say again.
219. Oh no.
Can't hear what's going on. 4,761, that sounds about right. And then here you get 74 squared is, geez, 5476, yeah. And then here you get 729, yeah. All right, and now, I mean, those numbers are huge, but again, they're based off of larger numbers, so relative difference. So here you get 1,024 divided by 100, that's easy, right? You have to divide by expected. Who's doing something? Let's see. Did you do the next one for me? Is that what that is? Doesn't seem like it. 300 into, maybe it is. 7.76, yeah. It just took me a minute to catch up to you. And then what's this one? Awk. 21.74. Let's see, does that make sense? It looks like it makes sense. And then this one should be like 9 point something maybe, or 8 point something. Whoa, wait a minute. Really? What am I doing wrong? What happened? I don't know about that either. 729 divided by 75.
9.72.
Yeah, it sounds about right. Those numbers look right. I was kind of going crowdsourcing those. Did you guys make it that far? Nobody wants to say?
Not me.
Looks like that one's wrong. Let me see. 5476 divided by 175 is 31.29 roughly, right? You guys all right?
Yeah.
With there?
Yes, 31.29.
4761 divided by 150, 31.74. Not sure what happened here.
I thought we're dividing by observed. Oh, it's by expected. That's why I'm off.
Yes. I
Yeah,
expect.
that's on me. Totally
Yeah.
bad.
No, that's okay. That's okay. And then, so this one is right because that one, let's see, that one's right, that one's right. And then the last one, I'm going to trust, I think, 9%. Okay, I like it. So I love it when that happens, when students are just like, I guess I don't know shit. But no, just speak up. It was a simple mistake. Okay. All right. And then when you add those up, what do we get? Let's see, 62, 72, 81, 82.46. You guys are going to make me do this? 82.46, 82.86, 82 point. Is that 83? 82, almost 83, yeah, 82.99. Neat. I like it. That's humongous. Right? All right. I know this is relatively new to us, right? But that's pretty damn big. Let me see. Where am I at? Okay, here we go. All right. So now let's look up together what the chi-square critical region is going to be, right? Let me stop sharing this and move over to you. Yes, okay. Where'd my mouse go? All right, so how many categories were there? I should have probably said that first.
4.
Yeah, there were 4 categories. I don't know if you guys can see it now. 4 categories. So degrees of freedom is oh, somebody's chatting at me. 3, okay. And then the alpha was 0.01, right? So I need 11.345 is my rejection region chi-square, right? 11.345. You guys see that? Okay, so then looking back here, we definitely blew that away. So I can't really draw the picture, unfortunately. I'm not that good with this, too bad. But we needed it to be, so 82.99 is definitely bigger than 11 point, whatever the hell it was. It went right out of my brain. 11 point, what was it? 3 something? Anybody write that down? No? I can look it up.
11.345, I think.
345. So 11.345 would be like the rejection region spot for a hypothesis test. And we blew that thing out the water with this, right? So really think about what this means. You guys know, is it better to have a low or a high number in this case? In general, in the population, is it better to have a low or a high blood cholesterol level?
Low.
Yes, low is good because cholesterol bad. All right, most is it LDL and HDL, all kind of crap. But so this is the bad type. So do you notice how this is what I expect to see, and this is what I saw? Do you see how much fewer of these people have high cholesterol and more of them have lower cholesterol? Do you guys see that? And we actually found evidence that they do not follow the expectation. So this would be something that would get translated. You guys remember, are you ever heard about the Mediterranean thing? Everybody just started guzzling olive oil because it was discovered that people that live in the Mediterranean area have much lower cholesterol levels and are much healthier. You guys hear that at all ever about olive oil? Like, oh, olive oil must be the answer when there's so many variables. There's so many variables involved. But they just latched on to the easiest one they could before it had been shown to be true. Maybe? So this is a surface level Statistical analysis. We have found evidence there's a difference. Why is the difference there? I don't know. It could be genetics. It could be in the water. It could be in the air. It could be more exercise. It could be their food just naturally has less bad stuff in it. Do you guys follow what I'm saying? No. Okay. All right. I like it. So the two main types of goodness of fit tests are the uniform expected, where you just divide the total by how many categories so they all get the same amount, or the percentage breakdown, where you take the percent of the total to see how much is expected in each category. I like it. I like it a lot. And you could, if you think about it, if you wanted to, you could put these in L1, these in L2. This would be L1 minus L2 parentheses squared. This would be L3 divided by L2. Do you guys, anybody follow what I'm saying? You totally could do those in your list. So you don't have to do each row separately. You can just make the calculator just spit it all out at once. Come on, calculator. Okay, maybe that's okay. All right, I like it. So I want to show you something else, since there seems to be no questions about that. I mean, relative to some stuff we've done in this class, this is not that horrific. I don't know if you agree with me or not. Let me see. I want to show you this. I'm planning on, oh, so where did I put you? There you are. Okay. Let me show you this. I'm going to put this up on Canvas. I don't know if it's going to help anybody, but this is looking a little bit long range with the final coming. I actually put this together a few semesters ago, this general kind of review of the whole semester. Oh shit, I got to take this part off. That of course is for last semester. Dadgummit. Uh-oh, my internet connection's unstable. Am I coming through okay? Everybody? Can you guys? You're all like, man, maybe if we don't say anything, he'll cut class. Can somebody tell me, am I coming through okay? Oh, it's laggy? Okay, so I'll end a little early. I was gonna do that anyway, but now there's even more reason. So I can reboot my router. So yeah, I'll edit this and put it up on Canvas. And then eventually there will be a practice final. There will be a practice final with an answer key to get ready for the final. You guys with me?
How much time do we have for final?
2 hours, like you were gonna have anyway. And the date and the time for the final is on the homework sheet, as it has been since the beginning. Is that all right?
Yeah.
Okay. All right. Otherwise, I got through everything I wanted to, so I don't mind ending a little early. Any questions about anything, guys?
I have a couple questions.
Yes.
The first one is the final. You said you're gonna observe us. Like, are we gonna be able to check the chats, like the Z-score, T-score? But like, I only have those in computer and I don't have how to check them.
I can barely hear you. Hold on. What's going on here? Let me change my, this might make me sound a little weird.
I'm gonna type it.
That definitely sounds weird. You're gonna type it? Okay, I can wait. I really couldn't make you out there. Could be my bad internet too, you never know. Anybody else have any questions or concerns, comments? The charts during the final, sure, yeah. You will be able to use them. I will, we only have access through the computer. Yeah, you're gonna have access through the computer to get the final exam. So I'll probably put all the charts together with the final. So when you go into Canvas to grab the final, all the charts will be there too. Yeah, I mean, otherwise, what am I going to do? Mail it to you? And then you mail it back? That'd be fun. Everybody remember, we already talked about the final exam, how it's going to work, right? It's going to be over Zoom. It's going to be really exciting. I'm pretty sure I asked you to make sure that you have the ability to turn on your webcam so I can actually watch everybody. That's going to be really fun. It's going to be really fun when somebody's internet goes out. It's going to be exciting. Technology is fantastic. Otherwise, I'm not sure how you're going to do it. So I'm trying to maintain some integrity by at least being able to watch you, and I could actually pull somebody in a breakout room and have them show me, like when you do the correlation, I'm going to pull people into a breakout room and then you can just show me your answer so not everybody can see it. You guys understand? So we're going to somehow make it through. We were all hoping maybe the pandemic would get to a point where we'd be able to go on campus for final exams, but it doesn't seem to be obviously anywhere near that. The conclusion is considered, the evidence is, oh yeah, sorry. So let's see, let's go back here. Let's write what the answer would be. That would probably help. Where to put it? There it is. Right? You guys see the problem again? Oh, what's going on? Do we have a quiz today? Yes. Yes. Remember? So as soon as this is done, I showed you earlier, it's going to be on Canvas. When you log into Canvas, you'll see it up there in chapter 12. Okay. Where to go? So what's the conclusion here? What's the answer? Holy shit, I don't want to footer. Go away. Stop it. We have found evidence that this group of people, have blood cholesterol levels different from what was expected. Bam. Either you have found evidence that the two groups are different somehow, or you have not found evidence, and it's telling me my internet connection is even more unstable. That's exciting. All right, I'm gonna cut things off right there. I'm not even sure if you guys are still receiving me. So soon, is anybody able to see me still?
No.
No.
What do you
The
mean
dots-
no? Huh? All right.
My
gonna type
showing
it.
no.
I'm not showing any document. Can you see me? I am going to stop this now and make the quiz active immediately. There.
Okay.
All right, guys. Bye. I'm going to reboot my router. Bye, everybody.